Hello and welcome to a new video in my Let's Code series. My name is Shin, and in this series we're gonna code something from scratch, and today we will code Tetris, as you might have seen in the title already, using Rust and Wasm again. So for those who do not know what Tetris is, here's an implementation of someone. I have no idea, I found this on Google. So basically there are these shapes that you are in control of, and the shapes are falling down from top to bottom, and your goal is to fill up the screen basically. And you can move the shape left and right, but it will fall down automatically on a timer. And the user can also rotate them like this. And the goal, as I said, the goal is to fill up the screen. And once you've got a complete line of things, which I'm trying to achieve here, once you get a complete line like this, the whole line disappears. And the goal is to fill up as much of the screen as possible, or not fill up. Clear as many lines as possible so the screen does not get filled up. That's the goal here. And you lose if you completely filled up the screen and no more tiles can be pushed down. So that's the gist of this game. A very classic arcade game. And I've recently learned that the company who invented this game has still copyright over this game. So I hope I'm not breaking any copyright law by doing this. Yeah, fingers crossed. Let's start from scratch, and we will create a new cargo project. As always, we will begin by writing the game model. Actually, we will begin by adding all the dependencies. There's this new cargo add command now. Let's try that out if this works. Oh, that's really nice, actually. Yeah, it does work. Okay. And we also need the random number generator library. Let's add that as well. Let's keep it simple like that. At first, we will begin by writing the model without any regards to wasm. So let us do that by creating a new file. And referencing the new file. Pub struct Tetris. So what do we actually need for describing the game state? So first of all, this operates on a two-dimensional grid as well. So we need the width and the height. And we need to describe all the shapes. And the best way, I think, is to define a new struct, which describes what shape we are doing. And the shape is nothing but a collection of positions. A set of positions. Let's call this positions. Let's make it a hash set. And the position is nothing but a tuple of numbers. For this implementation, I think we will stick to signed integers rather than unsigned integers. Let's use I32. Okay, and maybe this time we will actually have a struct. Define a struct as our position. And of course, the components are public. So this defines our shape. Now we need to have a current shape, which is the shape that the player controls. And we have fixed shapes. Not sure how to call this, but there are these shapes at the bottom that the player cannot move anymore. Let's call them fixed shapes, and which is let's say a vector of shapes. Okay, since we put our position struct into a hash set, we need to make this hashable. Let's derive some traits. We can clone copy that. We should be able to hash that. Look for equality. Let's also derive some traits on the shape struct debug, especially. Maybe we want to clone that. Okay, that's perfect. Now, if we look at the game itself, we already know, yes, we need a internal game timer again, just like in our snake game. And there are 4 ways that the user can interact with the game state. The first 2 are changing the position of the current shape that is falling down. That's 2. We can press left and right, move the shapes left and right. Second is rotating the shapes. The 4th interaction is speed up the game timer. By pressing the down button, the player can speed up the timer. Like that. And yeah, it's game over when no new shape can be put into the game anymore. As always, we will create a constructor for our game state. We need the width and the height. And we will return that. Fixed shapes would be an empty vector. So for the current shape, we need to think of something here. So we can use a randomly generated shape, or we can just hardcode one fixed shape at the beginning. Okay, let's extract the shape struct into a new file just for clarity's sake. We need to register it in our lib file, and we need to import shape into this file. Oh yeah, we need to also move the hash stat. Okay, we need to define all the shapes there are. So I've already opened the Wikipedia article. These are all the shapes that occur in Tetris. And let's just say I will define a constructor function for each of those characters. So let's call them, for example, new I. And then we will define all the positions and then do into iter and collect into a hash set. So for example, the I consists of 4 positions. It would be like pause 0, 0, pause 0, 1, 1, 0, pause 2, 0, pause 3, 0, something like that. And we need to keep in mind that we need to be able to rotate the shapes. So for that purpose, I think it's good to have also like an anchor. An anchor meaning the point in the shape where the rotating motion should be anchored at. And it's typically somewhere in the middle of the shape. So for the I shape, we will define the anchor as, let's say 1, 0. Okay, now I need to define constructors for all of the 7 shapes. So this takes a lot of time and there's a lot of boilerplate. So I'm thinking of writing a macro to speed that up. So to write a macro, we will begin by naming our macro. Let's say impl shape constructor. And we need input variables. There are input variables, and the output is the code that the macro has to generate. And we want to generate something like this. That is what we want to generate. And of course, we will have to define our constructor name. I'll call that new, which is an identifier. And we need also the positions. We want to have multiple positions separated by a comma. Let's call that position, which is an expression. And we need the anchor point. Let's say anchored at anchor, which is also an expression. Alright, let's fill out the placeholders. So instead of hard coding this, we can just loop over our variables. And then calling into iter and collect. And instead of hard coding the anchor, we will just use the variable anchor. Hopefully this will work. And instead of this, I can just say impl shape constructor for new I, which consists of these positions anchored at pos 1, 0. Let's make it look nicer. And you know what? Instead of only being able to define one constructor, let's also loop over all of that. We'll separate them by semicolon. And we will loop in the code output. Wait, what? Unexpected end of macro invocation. Oh yeah, the semicolon is not a separator, it's part of the expression. Yeah, okay. And then let's do that for O, which is also 4 positions. Okay, let's just duplicate the line, new O. And O consists of 0, 0, 1, 0, 0, 1, and 1, 1. And the anchor point is at 0, 0 as well. Okay. Maybe let's implement a random constructor. New random. Let random equals random get a new floating point number. There are 7 shapes, so I want a number between 0 and 6 inclusive. So I will have to multiply this by 7 and then floor it. We will get a floating number which we can cast as a U8, let's say. And then we will match random. 0 should be new I. 1 should be new O. Okay, this will take a while. Let's say T, J, L, S, Z. And here we have 2, 3, 4, 5, 6, and Anything else would be unreachable. Let's mark it as such. Okay, so we can also say, instead of hard coding the shape here, we can say new random now. And that's it. Let's just test it out real quick. Mod tests, test, fn test. Let's print a debug print of Tetris new. We need a size for that. Okay, maybe just for testing purposes, 510. Tetris doesn't implement debug, right? We need to derive debug for our game state, all right. Current shape is 1001, 1100. Hey, that's an O shape, right? Okay, what a coincidence. Okay, let's run the test again and see if we can get another shape. Great, that's definitely another shape. I don't know which shape, but that's all right. Next, we will implement our tick function. We will have to mutate our game state with every tick. Okay, hold on. Before we go implement the tick function, like our shape has this position, but we include also minus numbers because the shape doesn't care at which position it is. It's like invariant to translations. But for the game state, it does matter because we need to position our shape in the middle on the top of the game board, right? So we need to translate the shape to a correct position because -1 would then be outside of the game board and that would be an invalid state. To do that, I want to implement like a translate function. The translate would just take all the points in positions and the anchor, and it would just add the translation position to all the positions inside the struct. And instead of creating a new method on the shape, I was thinking maybe we can overload the add operator for that. So impl add for shape. Okay, hold on. Let's read the documentation for add first. Add has a right-hand side. Okay, let's say our right-hand side is not another shape, but a position. Output would be another shape. Right-hand side is now a position. The add method will consume our shape. Wait, is that what we want? I don't want to actually consume it. Okay, so let's impl it for a reference of shape. So we will create a new shape by putting in the positions from our old shape, iter it, and map it. And we will add the right-hand side to our position, collect it again, and do the same for our anchor. That's anchor plus right-hand side, something like that. Now this complains we cannot add position to position. And that's because we also need to overload our position struct with add. Let's do that real quick. Impl add for pos. Output would be a pos. And what we do is have a new pos with the old pos plus right-hand side x. And the same with the y coordinate. And now we need to dereference this. This is fine because pos is a copy type. Yeah, this is not a reference, so this works. Okay, or maybe let's do that. That makes it clearer. Now in the constructor of Tetris, we can now translate the shape, the position of shape using this plus operator, and we can translate it by, well, if we want the shape to be in the middle, then we need to divide width by 2. We would not need to translate it in the y-axis because all our shapes are already defined to be at the top. Yeah, we need to cast width to a I32. Let's not use U size then, let's use U32. It's still a little bit dangerous, but I think we're good. Let's run our test again, see if our shape is located in the middle. We need to make the width a little bit bigger to see an impact. Let's say 100. Yeah, it looks like it's the x coordinates are all around 50, so that's good. What are the actual dimensions of this one, this game? We can also do that, 10 and 30. And now to implement our tick function in the normal scenario, all we need to do is translate the current shape in the y direction. Something like that. Let's also try this out. Let Tetris equals this. Make it mutable. And then call Tetris.tick 2 to 3 times. And then the y direction is moved down to 3, 4, and 5. Yeah. But of course, our tick function cannot be that simple. So first of all, we need to check for collisions and out of bounds. So let's call this translated current shape, something like that. And then we need to check for collisions. Let's add some helper methods for that. Let's call this is out of bounds self and then a shape. And we will return a bool. All we need to do is to look into the shape, oh, I cannot get position from the shape because it is private. I think I want to keep the field private because I don't want the outside world to be able to mutate the positions vector. So I'm going to add a new method instead, positions, giving us, I don't want to give them the hash set per se, but I guess I can give out the iterator of positions. We would then give out self.positions.iter and then copy every item. And it is bound to the self lifetime. Okay, so we will check out positions and then we need to ensure that every position here is inside the game board. So pause, the x coordinates has to be greater equals 0 and smaller than self.width, and the same for the y coordinate, self.height. Okay, for convenience sake, let's define width and height to be also I32. And we will do the casting right here. as I32. How about that? This way, when constructing the game state, we will ensure that width and height are always greater than 0. And we would also need to implement something like is colliding, like a collision detection. This would check if the given shape collides with all the fixed shapes that are inside the game state. So we will get our fixed shapes, iterate over that, and we will look for any shape, fixed shape, which collides with our shape. And for that, let's implement another method on our shape. Let's call it collides with, and it will take another shape. And this will basically compare the hash sets. So we need to self positions. Oh yeah, I think there's an intersect method, right? Intersection. It will create a iterator. Okay, intersection, intersect with other. And we just need to count the number in their intersection. If it is greater than 0, then it collides with that. Otherwise, it's okay. Oh, I need other dot positions. Right. And here we will just call fixed shape dot collides with shape. So if is out of bounds, translated current shape, or is colliding then we need to finalize or fix move current shape to fixed shape, or make current shape fixed, something like that. So this means we do not update current shape. We can say we can take out the current shape. Let's call it new fixed shape. Would be taking out the current shape, but we cannot taking out the current shape leaving nothing behind, because the current shape should always be a shape. So we need to replace this. So the thing to do is using memory replace, and we want to replace self.current shape and putting behind a new shape, a new random shape like this again. Something like this. So we will take out a current shape, leaving a new random shape in place, and we have a new fixed shape. The new fixed shape we will write into our fixed shapes vector. And else, if it is not out of bounds and it is not colliding, then we will update current shape to translated current shape. Okay, now that's the tick function, and we now also need to implement the 4 user interactions, namely moving the current shape left and right, rotating the current shape, and speed up the game timer. Okay, since the game timer thing is completely outside of our game state, the game state doesn't define how fast the game timer has to go, so we can leave that out. So this leaves us moving the current shape left and right and rotating it. Let's first do the easier one. let's call this shift current shape, something like that. And we would also need a direction, which we will define in a minute. Direction is an enum, which consists of two variants, like left and right. Let's also derive some traits: debug, clone copy, equality. So we will match direction. And the same as tick, we need to look at translated current shape. And we will have to translate the current shape by a vector. For left, we will translate it by -1, 0. For right, we will translate it by 1, 0. And we will need to check for out of bounds and collisions. Okay, if self is out of bounds, translated, or is colliding, translated, then we will do nothing. Okay, wait, then let's invert the condition. In this case, we will actually update current shape to translated current shape. Okay, that was easy. And the rotating part will be a little bit more difficult. For simplicity's sake, let's just call it shift, because I don't want to write that much. So for rotate, it might be a good idea to add the method to our shape struct. Let's add a new method called rotate, and it will also give us a new shape. It won't mutate our existing shape, but it will give us a new shape. And yeah, we need to think about this. That's why I also have the blackboard going on. So what is a shape? A shape is a set of points, like they have coordinates xi, yi, and we have an anchor. This means all rotation needs to be relative to this anchor point. Let's call the anchor point a, b. A and b are the coordinates of the anchor point, which means to rotate any point, we would need to subtract the anchor point from it. Then we can rotate this point around the origin. Let's call the coordinates of this rotated one rx, ry. And then we need to add the anchor point again to the new rotated coordinates. So how do I rotate a point around the origin? Our function rxy rotates around the origin, like 90 degrees, counterclockwise. And I'm using a very simple trick to figure that out. I'm just reinterpret the coordinates as a complex number. So x is on the real axis and y is on the imaginary axis. And on the complex plane, rotating 90 degrees counterclockwise is as easy as multiplying this by I. And what this does is x times I plus y times I squared. So I squared is just -1, so this is just minus y plus xi, which translates to minus y comma x as a point. That means if I have xi, yi, I need to subtract my anchor point from the coordinates, and then I will apply the rotation, which is the same as swapping the components and adding a minus sign to the x component. This means we have minus yi plus b, comma xi minus a. And then we will have to add the anchor point again, which is minus yi plus b plus a, xi minus a plus b. Is that correct? Well, I mean, theoretically it should be correct. Okay, let's implement this then. So we will do self.positions, map it to, or we can destructure it into x and y components. So let's get the anchor first. Self.anchor a and b. So what did we say? We want minus y plus b plus a, comma x minus a plus b. And the anchor point, of course, being the anchor point, it didn't change, so we can just do that. We need to collect this into a set again. Okay, hopefully our theory is correct. If I rotate it, I need to do the same collision check. So let's copy the code from here and call that rotated current shape. And we will not do any of that, but call .rotate. Actually, the name rotate sounds like we are rotating in place, which is not the case because we are not mutating the shape object itself. We're just returning a new shape, which is the rotated version of current shape. So maybe let's rename this to rotated. I think that may make more sense. Rotated. If it is out of bounds or is colliding, then we don't do anything. If it is not, then we can safely replace current shape with that. Okay, these are the user interactions, and we need to code the losing condition, which we forgot. We should be able to put it in tick. So whenever we fix the current shape, we will generate a new shape, and we need to check if that shape is colliding with anything. If yes, we lost, right? Oh, let's add a new field called lost as well. Which means if self.lost, we will just don't do anything, return. Oops. Okay, here we go. And yeah, with all the user interactions, if we lost, then we just don't do anything. So let's add the losing condition here. If self.current shape, if self is colliding self, if the current shape collides with fixed shapes, then self lost equals true. And the game will stop. And what we also forgot to do is, like, when a line is full, we want to remove the whole line. Let's add some more helper functions. Is line full? We can ask. We will give the y coordinate and we will return a boolean to see if the line is full or not. For sure, we need to iterate over all fixed shapes. And we would need to iterate over all the positions of those shapes. So let's flat map it. Shape.positions. Oh yeah, since positions returns an iterator, let's rename this to iter positions. Now we need to filter out all the positions whose y coordinate is equals to y, and we will collect it into a hash set, just so we don't count multiple entries. We will count them. Len. And if len is equals to the width, then the line is full, right? As simple as that. We will cast len to an I32. Okay. And we need to have a method called remove line, which will have to mutate self and needs a y coordinate as input. Let's make this function private actually. Should not be called from the outside. We will iterate over all fixed shapes, but this time we want to mutate them, mutate the shapes. For shape in here, we would need to do something. Let's implement also a corresponding method on our shape called remove line. Takes a y coordinate. We can just say self.positions. I think we need to iterate it again. Iter and then copy everything. And then we will filter out all the positions that are whose y coordinates is not y. Here we go. Yeah, okay. So we will then have shape dot remove line y. But the problem is now that if we call remove line on a shape, then yeah, sure, the line is removed, but we also want that all the positions above the line, because of gravity, should come down. You know what I mean? We will also need to transform those positions. We need to check if pos.1 is below the line. Then we can safely return pos. Otherwise, we need to move everything down. So let's return a new pos, which is the same x coordinate, but we need to add 1 to the y coordinate, something like this. And yeah, we will call remove line for every shape, every fixed shape. Then even those shapes who do not have positions on the line in question will have to move their positions down by 1. And we also need a method called remove full lines, which will remove all the full lines. It will detect all lines that are full and then remove them. And for that we just need a simple for loop from 0 to self.height. If self.is line full y, then we will self.remove line y. Okay, and right after fixing the new shape, we will call remove full lines. Okay, I think that's it. I think we can move on to the UI part of the Tetris game. Yeah, because testing it out like this is really tedious, right? You don't get a graphical view of what is happening. inside the game state, you just see a bunch of numbers and need to interpret it. Hold on, what is going on? Why is there a fixed shape already? Lost is true? What the heck happened? Why is lost true? Wait, what am I doing in my test code? Okay, I finally found out what was wrong. Yeah, it seems like it's out of bounds. My out of bounds method is completely wrong. It does the exactly opposite of out of bounds, because this checks if it is in bounds or not. So we have to just invert this condition. I think that's all we had to do here. Okay, yeah, this was like my debugging session. I'm like, what the F? Oh god, I can't believe I missed that. But okay, let's try that again. We should not lose after 3 ticks. Yeah, we didn't lose. So okay, everything's fine. Everyone, everything's fine. Okay. So let's move on to the UI, shall we? Jeez. Okay, we need to make rand wasm ready again. Let me just Google that again, how to do that. Last time it didn't work because I think it's the same root cause as the error we had in our snake let's code video. Just because my path contained like a special character, which shouldn't be a problem now anymore. Okay, we need to activate get random with the JS feature. Cargo add, and we need features JS, right? Let's see if it did that correctly. Yes, I think so. Now for the UI part, I was thinking about using my new wasm-react library. So we can use the React UI framework we can write it in Rust using the wasm-react crate. Let's add that. Cargo add wasm-react. Now, first of all, we need to define our component as a struct. Let's call it app. We don't have any props because we will manage all the data using a state. So this is an empty struct. We will have to implement component for app. And we need to write a render function. Let me create a div. And we would need to, for each position, we want to write an emoji. So we need a way to iterate over all positions inside our game state. Maybe we can write that real quick. Let's call it iter positions as well. We will return an iterator with item equals pause. Okay, as usual, we've done it a couple of times in our previous videos. Let's iterate over all the rows. And then we will iterate over all the columns. Oops. So here we get the y coordinate and here we get the x coordinate. We will move y into here. And we will have to move the width into here, and to make this iterator not depend on our self lifetime, let's simply bind our width and height into variables here. And we would also need a method for getting the value of a position. And we will return, I don't know, let's return a string slice. And we will look at our fixed shapes. Actually, we will first look at our current shape and see if iter positions. Actually, in this case, I kinda want the hash set. Or we could just add a new method called hasPosition. And we will return .positions.contains pos, and we will ask about it in here. And we want to make it so that every shape has an identifier, not an identifier per se, like a unique identifier, but an identifier for the type. Yeah, let's add a new field called type, which would be a string slice. Let's make it a static string slice. And we need to update our macro so we can include our string slice in here. Let's make the syntax a little bit shorter by using the @ sign. And is there another error here? All right, I'm add type myself here. And let's add our type. Literal. And let's just add this for now. Okay, this will return a static string. Okay, if self current shape has position, then we will return the current shape type. Okay, let's we need to add a getter for our type. Okay. Oh geez. Okay. Here we go. Else we want to return an option, right? Okay. If there's no shape on the position, we will return none. And if it's not on the current shape, we also need to check our fixed shapes. Actually, we can just use this, put this into the else statement. So we need to look over our fixed shapes, and we want to find, actually we need to iter it and find the shape which contains the position pos, and then we will map it shape.type. Type is private, yeah, we need to get the function itself, right? Then it works. Okay, for our UI, we need to import our C macro for the children. And then we need to iterate over, actually we need to first define our state. Tetris, our game state. Use state, and we will create a new Tetris. Width and height. Actually, width and height can be the props of this component, actually. Okay, let's do it this way then. Actually, we said let's use U32, right? So self.width and self.height. Tetris is now a state, and we can look into the value and iter over all the positions. And we have positions in here. And for each position, we will get the type by calling tetris.value.get. Return something consumable. Okay, type is now an option of a string slice. We can put it in here, unwrap or default. Default being the empty string slice. Okay, and then we can export component. App. And to do that, we need to implement from JS value for our component struct. So let's do that, from JS value for app. And we would need to supply the width and height fields, which we can by adding websys to toml. Okay, we need to cargo add websys. Actually, I don't need websys, I need JSs. Oops. Let's remove websys again. Okay, because I need the reflect module to get from value the key width. Wait. Actually, I need to implement try from. Oh. Yeah, my fault. Error would be JS value. Okay, here we go. Propagate the error and get it as a float number and casting it into a U32. And the same for height. What am I doing? Oh, this will return an option. Okay, I can unwrap or default. Actually, let's provide sensible defaults. What did we say? Width is 10 and height is 30. Okay, now export components will work, and we have that. Let's compile this and see what it looks like. wasm-pack build -- target web. Oh, yeah, add the crate type. And in the meantime, we will create an index HTML. Let's call it Tetris. We don't have a style sheet, no script. We will add a div called root and add a script. And now we need to import React. We can use modern ES module syntax for that, but oh yeah, type has to be module. Okay, and now we need to import our generated code. Init from package tetris.js, and there should be something called a struct called app inside there. Let's check real quick. Yep, app. And let's write a... Actually, since this is a module, I can use top level await, right? We will init it. Also, we need to import wasm-react because we need to tell wasm-react to use our React runtime. And then we can call React render. Create element of app inside the div with the ID root. Okay, that should be good to go. Let's run a static file server. This time I'm using sfz, that is a crate written in Rust. So it will serve on localhost. And we can look at our index.html, look at the... Oh, I don't have React DevTools installed in this profile. Okay, we need to do without it then. But as you can see, there are a lot of divs generated here. And it seems like our first shape is an O shape. If I reload, it will change. Right, and the random number generator works as expected beautifully. Okay, we just need to make this a little bit look nicer in our component. We can add some styles. Let's add a display inline grid. And we need a grid template of... I've done it so many times, but I always forget the syntax. So let me look it up real quick. Make them 1 EM big. So first the rows, then the columns. This means the height comes first, right? Self height. Oh, I don't think this works. Self.height, self.width, something like that. Let's also add a border. Let's build again. Okay. Yeah, not bad, not bad. This is not in the center. We probably want some global styles to make the font a little bit bigger. Font size, let's say 2 EM. Okay, that's a little bit much. 1.5 EM. Okay, fits perfect onto the screen. Exactly, we can even specify our dimensions in here. Let's say I want height equals to be 25. Then this works. Yeah, now it's smaller. Okay, next we will have to program our game timer. For this we will use an effect with dependencies none. Oh, now we actually need websys. Okay, let's add websys then with some feature flags. Okay, now we can say window dot unwrap throw dot set interval. Okay, yeah, that I don't even need document then. Okay, let's remove document again. And let's look at the syntax. We need set interval with callback and timeout and arguments 0. Okay, that's what I need. We need the function and the timeout. Let's put timeout at half a second first. And wrap throw. And we will return a destructor as well. We would need to define our closure. So closure new, and we can define our closure like that. And then actually we need to move Tetris into our effect. Okay, let's do that real quick. So let Tetris, we need to clone it. This is fine because this is a reference counted reference anyway. So we can just clone it. And we need also to clone it into our closure as well. Oh, this is wrong. Hold on. No, that's correct. What is wrong here? Consider giving tick closure the explicit closure T. Why? Okay, hold on. I'm solving this later. And what this interval does, it just needs to set Tetris again. And we would have to call tetris.tick and then return Tetris again. That's what we need to do. And this needs to be mutable. Okay, this tick closure, we will put it in here. Tick closure as ref. I can cast it into a function if you want. Unwrap. Okay, and to make sure that the tick closure lives during the entire lifetime of this component, we want to move it into the destructor, which we have to do anyway because we need to call clear interval. Clear interval with handle. Okay, and I need a handle. Okay, the handle I get from here. Let handle equals this. And we can clear interval with handle and we need to move tick closure into here. This looks stupid, but we have to do that because otherwise tick closure will be dropped. Right, we can say drop. This makes it a little bit clearer. Okay. Oh, okay, let's see if this works. Oops. Okay, yeah, it's working. Okay. Now we have the tick, but we cannot move the current shape around. And when it reaches the bottom, it should get fixed and a new shape should spawn at the top. Beautiful. Okay, we really need to fix the centering thing because the shapes are not centered and it is bothering me so much. Okay, let's see. In our new function, we are adding half of that. Is that okay? I feel like we should do width -1 and then divide it by 2 or something like that. And we also need to change the tick logic. Here we go. Okay, this looks kind of centered. Not perfectly centered, unfortunately. Well, this one actually looks better. Okay, Yeah, to make this look nicer, instead of characters like this, we should look for some emojis to spice it up a little bit. Yeah, we have several colors. Let's look up the official colors on Wikipedia. So the straight one eye is supposed to be light blue. Okay, let's just do blue, I guess. O is yellow. Okay. Okay, this looks very good already. There's some, I don't know, inconsistencies. I don't know what's happening there. Oh, it's the same thing as last time. Like, the emojis are not really centered. Really not sure what to do about that, to be honest. Okay, I will add text indent and margin top. Text indent minus .2em and margin top. That should fix the layout problems. Okay, let's listen to the user interactions as well. So this effect is for the tick. And then we need to add some event listener to our div. For that we can define handle key and use the use callback hook. We need keyboard event. Dependencies. There are no dependencies, I think. And we will register our handler on key down. Right, handle key down. Okay, and let's look up the key codes. So we want to look for event.code, arrow left and arrow right. Let's match on event.code. Right. We want key left, arrow left, arrow left. Arrow left would be direction left and arrow right is direction right. Let direction equals wrap it into a block. So if anything else is pressed, then direction would be none. Right, we will make this into a string slice. I said make it into a string slice, thank you. If direction is sum, we will have to mutate Tetris. Okay, we need to move Tetris into it by cloning Tetris again. And making it mutable. We can set. We can call shift on our Tetris scheme state with direction specified and returning Tetris again. Okay, let's see if this works. It doesn't. I think this is because our div cannot listen to key down events because it has no focus. So let's make our div focusable, which means assigning it a tab index and making it autofocus. Okay, autofocus does not work, but it is now focusable and it can listen to key presses. Yay! This is nice. Okay, autofocus does not work here, but on key down works. Let's make it look nicer by getting rid of the outline. Okay. Let's put the code into an own variable because we do not want to encode and decode the code every time we want the code. If code equals arrow up, we will also rotate our current shape. Let's see if that works as we expected. Yeah, that is nice. If I'm in the edge, I cannot rotate anymore because it doesn't fit. Okay, now I just need to put in the speeding up bit. For that, I will add a new state called speed. At the beginning, it should be the default speed, namely 500. And whenever speed changes, I also need the effect to change. And this would then be speed.value. What is happening? Oh yeah, we need to clone speed. Actually, I don't need to because I can get the value instead, and then the value is an integer which I can simply copy into the closure. And now whenever I get key down and code is arrow down, I can mutate my speed. Okay, let's also get the speed in here. So speed.set, and I will double the speed, I guess. And we also need a handle key up. Let mod speed equals speed.clone. And we have a keyboard event. And the dependency, it has no dependencies. And I will do the same thing here, but just restore it to the default value. Yeah, move. And I will need to register that key up. Let's see if this works. Yeah, it's a little bit faster. Okay, it can be even faster, I think. 100 milliseconds. Whoa, the rotation looks weird on this one. Did I mess up the anchor for this one? Wait, T, where's the anchor? 0, 0, well, that's wrong. It has to be 1, 0, 1, 0 is the anchor. Okay, yeah, now it's correct. Yeah, this looks much better. Okay. Now the moment of truth. Yes, okay, that went well. I want like multiple lines, so I'm waiting for a... Yes! Beautiful. The Tetris god has heard my prayers. Okay, that worked. Nice, okay. Okay, one bug that I found is that I can suspend the shape in midair by keep pressing the down button which is definitely not what I want, because that's like pausing the game and the player then can cheat. I feel like this should be even faster, 15 milliseconds. Okay, yeah, this feels better, and no human is able to press the down button fast enough so that the shape is suspended in midair. Unless, you have superhuman speed or something like that. Okay, let's make it so that our div will autofocus once the component is mounted. We will also use an effect for that with no dependencies. No destructor. And we would need to create a ref container for that. So let's do that. Let element container equals use JS. Hold on. Okay, somehow my recording software crashed, but thankfully there was no data loss. I don't know what happened, but here we are again. What are we doing? We want to autofocus our div, right? Okay, yeah. That's why we have a ref container here. We want to save the HTML element in a ref. Use JS ref none, and then we can use element container in here. And in our effect, this effect will be run when the component mounts. So we can say something like remove element container in here, current dot what does current return? An option of an element, map element dot focus. Can I focus that? Okay, no, I cannot. Maybe I need to dyn ref into an HTML element. And I think we need to add HTML element to websys. That's it. Yes. What is happening? Okay, apparently I need to define this here. Can I use HTML element? I don't think so, because ref container needs an element ref. Maybe this can be improved in the future. Oh, I cannot move this. I need to clone this. What is happening? Cannot return reference to function parameter element. Okay, oh, I need to dyn into because I own the element. Right, let's use and then, because dyn into returns, okay, it returns a result which will turn into an option. And then we have an HTML element which we can hopefully focus on. Exactly. Alright, let's try that out. Here we go. And yeah, and the div is automatically focused. Unfortunately, when I click outside the div, I lose the focus to my div and I cannot use my keys again. It's probably a better idea to not handle the key down events on this div level, but to handle it on the document level. Yeah, probably that would be a better idea. Okay, I think this is it. I think we have a minimal viable product here, which is really nice. This is very playable. I think that took me quite a long time, like compared to the previous two videos. Anyway, this is pretty fun to play. So this can be, of course, improved. Like I said, the event listeners could have been on the document level, not on the div level. I think that would make more sense, but for the purpose of showing my library, wasm-react, I think this is okay. Maybe make it so that when our div loses the focus, that the game will pause automatically. Because if the div doesn't have focus, I can't even control my shape. I cannot play the game. So this is a nice improvement. And also, like when the player loses, it can also show a message. You can play around with animations. Adding music is of course always... Music and sound effects would also help the experience. Also, you can't restart the game in the browser. We could have a new game button somewhere, or a button to give up. Or other improvements could also be like showing a list of shapes that will come next at the side. I think that's also pretty common for Tetris. Yeah, but all in all, I'm very happy about how this turned out. With that, thanks for watching again, and if you haven't seen my previous videos, the playlist is linked in the description below. Also feel free to let me know what else you want to see me code in the future, what other games. I am running out of ideas, to be honest. Okay, with this, I'm signing off. See you next time, hopefully, and have a nice day. Bye!